Hi everyone, I'm Cheryl. In this problem, we're going to evaluate the given limit algebraically, but then we're going to use a graphing utility to help verify my result. So let's begin by taking a look at this limit. I want to see what happens as x approaches 0. Now you may at first think you can try just plugging 0 in, but if you do that, we're going to get 1 minus 1 in the numerator, which is 0, and in the denominator we'll also get 0. This is 0 over 0, which is an indeterminate form. So that tells me I need to do something else to my expression so that I can evaluate the limit. Well, because that expression is a compound fraction, let's go ahead and get a common denominator in the numerator. So I'll write this as the limit as x approaches 0 of 1 minus the quantity x plus 1 all over x plus 1. As I said, I got a common denominator in the numerator, and the whole thing is still divided by x. Well, if I continue with my algebra, I can say that I've got the limit as x approaches 0 of 1 minus x minus 1 all over x plus 1 all over x. And this leads to the limit as x approaches 0 of negative x all over x plus 1. Now, instead of dividing by x, I can also multiply by 1 over x. It's the same thing. So now I notice that I can rewrite my limit as the limit as x approaches 0 of negative 1 all over x plus 1, because my x's cancel. Now, what happens as x approaches 0? Well, as x approaches 0, my expression is going to be approaching negative 1 all over 1, which is minus 1. All right, so now we're going to use a graphing utility to verify my result. What you want to do is enter the function 1 over x plus 1 minus 1 all over x, and then graph it. Now, it would be helpful to use a window of minus 5 to 5 on the x-axis and minus 5 to 5 on the y-axis as well. When you take a look at the graph, you can use your trace key to look at what happens to the curve as x approaches 0. And you'll notice that as x is getting closer and closer to 0, the y value is getting closer and closer to negative 1, just as we calculated. Now, you may notice that if your trace takes you to exactly the point x equals 0, the function will be undefined. But remember, we're only looking for the limit. We want to know what happens, we want to know what the function gets close to as x gets close to 0, and it gets close to negative 1. I hope that was helpful. Thanks.